Alright, so this is going to be a video about average atomic mass. And what average atomic mass is the weighted average of the masses for the isotopes of a certain element. So it's exactly what it sounds like. The average of the mass of certain atoms of the same element. Okay, we went over weighted averages in the last video. In the video before that one, we went over isotopes. So you should understand these two principles. If not, you're going to need to go back and check on those. Okay, so our first example, the only example we're going to go over actually is carbon. So carbon on the periodic table looks like this. It's got a 6 for the atomic number, C is the element symbol, and then it's got an atomic mass, that's what this number is down here, atomic mass, of 12.011. Okay? This atomic mass is an average, and that's a big principle that you have to understand when you're understanding average atomic mass. No single carbon atom has a mass of 12.011 atomic mass units, not one. Okay, this is an average, and by average that means that it's going to have many different samples that make up what it is. So for the two samples in this case with carbon, it's carbon 12 and carbon 13. If you remember our hyphen notation and our nuclear notation for these two isotopes of carbon. Okay, now if you took a sample of, this is what scientists do, they would take a sample of carbon in a certain place and say it had 100 atoms in it. So this is the sample of carbon all around. About 99 of them out of the 100, say they took 100, about 99 of them would be carbon 12. So act like this is 100 of them or 99 of them and they'd be carbon 12. Now about one of them, in this case it's 1.1%, is going to be carbon 13. So one of them is going to be a little bit heavier than the rest of the 100. Okay, we need to find an average mass of all of those atoms, all of these isotopes. And we're going to do that based on the principle that we used last time with weighted average by multiplying the percent abundance by the atomic mass. So it's going to look like this. So we know that carbon 12 has a mass of 12.000 atomic mass units. So we're going to take our 98.9% and turn it into a decimal. So we got 0.989. I'm going to multiply it by this mass, the 12.000 atomic mass units. Okay? This is just straight from the weighted average thing we went over in the last video. Okay, right here we have the 1.1, and this is going to be 0.11 as a decimal, because we're going to move that decimal place over twice because you're dividing it by 100. You should know how to go from percent to decimal. And then multiply it by the mass of carbon 13, which is 13.003 atomic mass units. Alright, if you plug this in your calculator, you can do that right now, you should be getting 11.868 atomic mass units. And then you're going to add that to, if you put this in your calculator, you'll get about 0.143 atomic mass units. If you add this together, you will get 12.011 atomic mass units, which is exactly the same as our atomic mass that's in the periodic table. And you can always check your work on this. If you look at the periodic table, the atomic mass that you calculate should be really close to what it says on the periodic table. It might be a little off depending on how you round, but it should be really, really close. Okay, so here's an example of average atomic mass with a problem. And again, if you have any questions, please let me know.